Hi there, in the last video I went through the proofs of the derivatives of inverse hyperbolic functions, hyperbolic sine x, hyperbolic cos x, as well as hyperbolic tan x. So I just went through the inverse derivatives of those three functions. Okay, I'm going to give you some additional results based on those standard results, and then we'll go through some examples in the next video. So here's some additional results. Number one, if y equals a hyperbolic sine inverse ux, so over here a is a constant and ux is a function of x. So where a is a constant and ux is a function of x, okay, then in order to prove the derivative you need to use the chain rule. Okay, let me just give you the results straight away though. dy over dx will be, okay, a divided by the root of, okay, u squared x plus 1 times du over dx. Okay, so this result is true if a is a constant. So if a is a constant, and remember from the standard result, if you differentiate the inverse hyperbolic sine of x, it's 1 over the root. So it's going to be 1 over the root, in this case u squared plus 1, but in these results you multiply by d by dx of this term. So you always do that, okay, when it comes to results of this form. So this result only is true, so we can only use this result rather if a is a constant. If a is a function of x, we may need to use the product or quotient rule depending on the nature of the function. Okay, let me give you another result. So if y equals a hyperbolic cos inverse ux, again you can get this result from the chain rule. dy over dx should be a over the root u squared x minus 1 times du over dx. And finally, result number 3, if y equals a hyperbolic tan inverse ux, dy over dx is equal to a over 1 minus u squared x times du over dx. Okay, so once again you can only use these results if a is a constant and ux is any function of x. So remember, if a is a constant you can apply these results. However, if a is a function of x, it's either the product or quotient rule. So okay, on the reverse side, example number 1, let me underline that in red. Okay, question is, let's find dy over dx, and in part A, okay, y equals, let's say, 2 hyperbolic sine inverse 2x. So y is equal to 2 hyperbolic sine inverse 2x. Okay, so what I normally say to myself is, this term in front of my hyperbolic sine inverse function is a constant. Okay, and if it is a constant, I can use this result over here. So you can only apply this result if a is a constant, remember. So in this case, dy over dx is equal to, I'm going to leave the 2 as it is, 2 is a constant, so it's a 2 over the root of, okay, our ux is 2x, and remember it's a ux which is 2x squared, okay, plus 1, but you need to multiply by d by dx of ux, and ux is this term here. Okay, so we're multiplying by d by dx of ux, which is 2x. Okay, now we can simplify this further. D by dx of 2x is simply 2. So dy over dx therefore will be 2 times 2 here is 4 over the square root of 2x squared is 4x squared when expanded plus 1. So that completes that example. Okay? So remember, we only apply the result if the term in front of the function is a constant. So in part B, supposing if y equals 5x, so it's 5x hyperbolic tan inverse x. So 5x hyperbolic tan inverse x. So just to remind you, we can't use this result over here because a is not a constant. A in our example here is 5x, a function of x. So if it is a function of x, we need to use the product rule in this case. Okay, so it's a multiplication or product of functions. So I take u as 5x, v the remaining term hyperbolic tan inverse x. So by product rule, let's call this step number 1. Let's remind ourselves of the product rule. Dy over dx is v du over dx plus u dv over dx. Okay. Now in step number 2, I'm going to do a side calculation because we need du over dx as well as dv over dx. So u is 5x. When I differentiate, du over dx is simply 5. Okay. Another side calculation, v is the inverse hyperbolic tan of x, and remember the derivative is a standard result. dv over dx should be 1 over 1 minus x squared. Okay, so that takes us to step number 3, and step number 3 is replacing these results from the side calculations into the formula. Okay, so dy over dx will be v is the inverse hyperbolic tan x times du over dx being 5 plus u, which is 5x, times dv over dx, which is 1 over 1 minus x squared. Okay, so if we simplify that, so simplifying further, okay, so what you could do is I'm going to take out a common factor of 5, and by taking out a common factor of 5, so 5 is common to both terms, I'm going to be left with the inverse hyperbolic tan of x plus the x over here over 1 minus x squared. Okay, so that completes this example. Let's try another example. So let's try an example on a fresh page, so part C. So if y is equal to 7 hyperbolic tan inverse hyperbolic sine 3x. Okay, so 7 hyperbolic tan inverse hyperbolic sine 3x. So all of this is one function. Okay, so remember the term in front of the function, the inverse function, is 7. Okay, so all of this is one function, so the term in front of the function is 7. So since 7 is a constant, I can use this result that we derived. Okay, so it's going to be 7 a constant over 1 minus our ux squared times, not forgettingly, the d by dx of ux. Okay, so dy over dx here is 7 over 1 minus our ux is hyperbolic sine 3x, so hyperbolic sine 3x, don't forget to square, times d by dx of ux, which is hyperbolic sine 3x. Okay, so further to that, when you differentiate hyperbolic sine, you get hyperbolic cos, so it's a hyperbolic cos 3x, but you need to multiply by d by dx of 3x. Okay, so that's from the chain rule. So d by dx of 3x here is 3, so dy over dx will then be 7 times 3, 21, hyperbolic cos 3x divided by the 1 minus, and I'm going to write this as hyperbolic sine squared 3x. So that completes this example. Okay, so let's try one more. So a part D. Okay, so y is equal to 8 e to the power hyperbolic sine inverse. So y is equal to 8 e to the power hyperbolic sine inverse 2x. Okay, so the term in front of my exponential function is a constant. So remember, when you differentiate an exponential, it's the same term, but you multiply by the derivative of the power. Okay, so you only do that if the term in front is a constant for an exponential. So dy over dx will be 8 e to the power hyperbolic sine inverse 2x multiplied by d by dx of hyperbolic sine inverse 2x. Okay, and let me do this as a side calculation. So as a side calculation, d by dx of the inverse hyperbolic sine 2x. So remember, the term in front of my inverse hyperbolic sine function is 1. 1 is a constant, so it's going to be 1 over, okay, the root of our ux is 2x, so it's going to be a 2x squared. Okay, so remember that comes from the result here, so it's root of ux squared plus 1, but don't forget times d by dx of the ux term. So 2x squared plus 1, so let's complete that, times d by dx of, and ux is 2x. Okay, so d by dx of 2x here is simply 2, so we'll have 2 over the root of 2x squared when multiplied out is 4x squared plus 1. Okay, so I hope you can see that. So if I do the replacement, dy over dx is going to be, so using this result in the main calculation, 8 times 2 is 16, so 16 over the root of 4x squared plus 1, okay, and don't forget the e to the power hyperbolic sine inverse 2x term. Okay, so that completes this example. So that completes this video. I hope you found this video helpful. Do practice questions, and I hope to see you in the next video. Thank you.